Hello, everyone, and welcome to Learn a Trade Academy. My name is Kevin Tate, and today I will be going over the EPA certification exam. It's a preparatory manual that I will be going over with you. This will be a series of videos to get through the complete manual. And if you watch this video through and take notes, and you'll be able to go back to the video if you need to get questions answered or whatever, and you'll be able to possibly sign up and take your certification exam, your EPA certification exam. As I said before in other videos, this will, enable you to get hired with a service company, and a lot of times service companies in the commercial food service equipment industry, they require you to have an EPA certification at least. And as you go, as you grow in the business, in the industry, you can then move on to getting your license, any licenses that you might need, your contractor license, or and be able to create your own employment, your own contracts and stuff like that. So I'm going to get into it. Like I said, this is going to be a series of videos. So, by all means, if you can, like this video or like all of them, and share them with people that that might be interested in getting into the field. The field of commercial food service equipment, HVAC, refrigeration. Pass it on, pass it on to them, definitely. And also, please subscribe. I'm trying to build this channel up and build up the brand, Learn a Trade, and, help some people out to be able to get into a field that has steady employment. There's never layoffs. The pay is really great. Anybody that's in the field can tell you, it's a lot of times it's long hours. Sometimes it's strenuous work, but it all pays off in the end. So definitely, pay attention to the video and, take notes. I'll be going through a lot of theory and, a lot of details. So, pay attention and, please, get a pad and pen, take some notes, sit down, and we'll go through this. I'm just going to see if I can set up the first clip here. There we go. This is an introduction. This manual is intended to prepare technicians for the service certification test and contains all the information a technician will require to successfully complete the test. So this block of instruction that I'm giving, it's going to give you all the information that you need to successfully complete the test and pass. This booklet is not intended to be a formal refrigeration training course. Technicians should be familiar with the basic vapor compression, refrigeration cycle, and common service equipment procedures. And basically, like I said before in other videos, that this stuff that I'm putting out, it's not a formal education in any way, but it will give you the knowledge, and it will enable you to be able to take your test and pass it. So you do have to have some basics as far as refrigeration goes, and a lot of people that are interested in getting into the field have already gone through their formal training, or are there in the process of going through their formal training. But this is definitely going to help. It's technicians that are in the field now could even use this as a as a refresher course, or if they're stuck on a job, they could take a look at these videos and possibly figure out what's going on with the equipment they're working on, due to the information that I'm giving to you on these courses. So this manual has been assembled with the most current information available at the time of this edition. Should EPA regulations change after a technician becomes certified, it is the responsibility of the technician to comply with any future changes. The EPA also reserves the right to modify the test questions and or call for a new certification based on advancements in future technologies. The ESCO Institute, which is from where this manual is from, they will update this manual as necessary to keep current with EPA rulings. Section 608 of the Federal Clean Air Act requires that all persons who maintain, service, repair, and dispose of appliances that contain regulated refrigerants be certified in proper refrigerant handling techniques as of November 14th, 1994. So, you do have to be certified to work with refrigeration, and that's the purpose of this course. That's the purpose of Learn a Trade, is to be able to help technicians out when they're in the field, and be able to help those who are looking to get into the field acquire more knowledge, so that they can proceed to gain employment in this field. There are 4 categories of technician certification. Type 1. This is a person who maintain, service, or repair small appliances must be certified as a Type 1 technician. Type 2. Persons who service, repair, or dispose of high or very high pressure appliances, except small appliances and motor vehicle air conditioning systems, must be certified as Type 2 technicians. Type 3. Persons who maintain, service, repair, or dispose of low-pressure appliances must be certified as Type 3 technicians. Universal. Persons who maintain, service, or repair both low and high pressure equipment, as well as small appliances, must be certified as universal technicians. The test format. The test contains 4 sections: A, 1, 2, 3. Each section contains 25 multiple choice questions. A technician must achieve a minimum passing score of 70% in each group in which they are to be certified. For instance, a technician seeking universal certification must achieve a minimum score of 70%, or 18 out of 25 correct, on each of the sections of the test. If a technician fails one or more of the sections on the first try, they may retake the failed sections without retaking sections on which they earned a passing score. In the meantime, the technician will be certified in the type for which they received a passing score. This is one exception. A technician must achieve a passing score on Section A to receive any certification. Section A contains 25 general knowledge questions concerning stratospheric ozone depletion, rules and regulations of the Clean Air Act, the Montreal Protocol, refrigerant recovery, recycling and reclaiming, recovery devices, substitute refrigerants and oils, recovery techniques, dehydration, recovery cylinders, safety, and shipping. Section 1 contains 25 sector-specific questions pertaining to small appliances. Section 2 contains 25 sector-specific questions pertaining to high-pressure appliances, and Section 3 contains 25 sector-specific questions pertaining to low-pressure appliances. The law requires the test to be a closed-book exam. The only outside materials allowed are a temperature pressure chart and a calculator. Certain personal information is required on the exam. Technicians should be prepared to present picture ID, social security number, home address. Technicians should carefully study Sections A and the sections related to the type of certification in which they are seeking to achieve a passing score. Core, Section A, General Knowledge, Stratospheric Ozone Depletion. The introduction of CFCs and HCFCs has dramatically changed our lifestyles. Little did we know that the use and release of these compounds into the atmosphere would have far-reaching effects on our environment. The greatest effect is in the stratosphere, far removed from the Earth's surface. The stratosphere is the Earth's security blanket. It is located between 10 to 30 miles above sea level and is comprised of, among other things, ozone. An ozone molecule consists of 3 oxygen atoms, O3. Ozone protects us from harmful ultraviolet radiation and helps maintain stable Earth temperatures. Stratospheric ozone depletion is a global problem. Depletion of ozone in the stratosphere causes crop loss, increase in eye diseases, skin cancer, reduced marine life, deforestation, increased ground level ozone. Remember to note this stuff here, people, because this may possibly be on the exam. CFCs have been found in air samples taken from the stratosphere. CFCs and HCFCs, when released into the atmosphere, deplete the ozone layer. The chlorine in these compounds is the culprit. When a chlorine atom meets with an ozone molecule, it takes one oxygen atom from the ozone. This forms a compound called chlorine monoxide and leaves an O2 molecule. The chlorine monoxide will collide with another ozone molecule, release its oxygen atom, forming two O2 molecules, and leave the chlorine free to attack another ozone molecule. A single chlorine atom can destroy 100,000 ozone molecules. There has been a great deal of controversy over the subject of ozone depletion. Some believe that the chlorine found in the stratosphere comes from natural sources such as volcanic eruptions. However, air samples taken over erupting volcanoes show that volcanoes contribute only a small quantity of chlorine as compared to CFCs. In addition, the rise in the amount of chlorine measured in the stratosphere over the past 2 decades matches the rise in the amount of fluorine, which has different natural sources than chlorine. Over the same period, also, the rise in the amount of chlorine measured in the stratosphere over the past 20 years matches the rise in CFC emissions over the same period. Unlike other chlorine compounds and naturally occurring chlorine, the chlorine in CFCs will neither dissolve in water nor break down into compounds that dissolve in water, so they do not rain out of the atmosphere. Ozone depletion potential. Ozone depletion potential, ODP, is a measurement of CFCs and HCFCs' ability to destroy ozone. CFCs have the highest ODP, ozone depletion potential. HFCs, which is R134A, do not contain chlorine and have no ozone depletion potential. And then you can see the chart here with the CFC, R11, R12, R500. These all have chlorine carbon in them. The HCFC is R22 and R123. They also have hydrogen, chlorine, fluorine, carbon. And presently, I've been aware of that R22 has been banned. It's not really being sold in your conventional places, your conventional warehouses or refrigerant distributors. There is an alternative. There's a kit that works the same as the R22, but it's not as harmful. And the HFCs is R134A, as we read up here. And they do not contain chlorine and have no ozone depletion potential. Okay, so this is why you see a lot more of systems with the 134A. Next, I'd like you to look at this diagram here. I'm going to go through this and then I will explain it. This is a diagram of your gauge manifold set. Okay, and as you can see, the blue is your compound gauge, the red is your high pressure gauge. Okay, and these are the valves that will open and close depending on how you turn it. And then these are your lines, and you have a blue line, a yellow line, and a red line. That's your hoses. Okay, those are your hoses. And now let me go here. And the gauge manifold, it's one of the most important tools to the HVACR technician. Is the gauge manifold set. Okay, so one of the most important tools to a HVACR technician is the gauge manifold set, and that's what you see in the diagram above. Okay, right up here, so you can see it. The compound gauge is blue, and the high pressure gauge is red. They are connected to the manifold, okay, right up here. Okay, they connect right in there. And the manifold is then connected by hoses, okay, to access ports to measure system pressures. The compound gauge measures low pressure, PSIG. Okay, that's the unit of measure that these gauges use. The vacuum the high pressure gauge measures high side discharge pressure. Okay, that's the red gauge. And the manifold is also equipped with a center port. Okay, that's that center port right here. That's what they're talking about. And there's a yellow hose attached to it. Usually it is a yellow hose. I have seen instances where a hose may have burst or it's not working correctly, and you only have like a blue hose or a red hose. But as long as you know that that hose goes on that middle port, okay, then you'll be all right until you could get a new yellow hose. You know, you really want to stick with your color codes in this business. As color codes are very important. So that middle port, that can be connected to a recovery device, okay, which would be a recovery tank. All right, most times those recovery tanks are gray. They're like painted gray. And then an evacuation vacuum pump or charging device. These are devices that you can hook those hoses to. Okay, EPA regulations require that hoses be equipped with low loss fittings that will minimize refrigerant loss when hoses are disconnected. Okay, so I don't have a picture of this fitting they're talking about, but the fittings would be down here and up here, okay? And those low loss fittings, what they're talking about is fittings that will, when you when you take the hose off or when you're putting the hose on a device like a vacuum or a recovery tank. When you do the recovery of the refrigerant, they 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 prefer that the technician have those type of fittings on their hoses so that when you take the hose off of a recovery tank, it won't let out a lot of the refrigerant, a lot of the gas. It won't come out. Very minimal. Okay, you'll hear like a hiss sound, like you're pumping a bike tire, and then when you open it up, you hear that sound when you pop it off, when you're done pumping the tire. And that's the same thing. You get a low loss of air, very little, so you're not putting any harmful CFCs in the atmosphere. Okay, so that's very important. Your gauges. It's a very important tool. Okay, next we're going to get into the Clean Air Act. The United States Environmental Protection Agency, the EPA, regulates Section 608 of the Federal Clean Air Act. Failure to comply could cost you and your company as much as $27,500 per day per violation, and there is a bounty of up to $10,000 to lure your competitors, customers, and fellow workers to turn you in. So that's very important, this piece here. This is, great information to, be aware of. If you're out there working on equipment and you're not, certified, you're not EPA certified, you should not be working on the equipment. So this is something to always keep in mind, and this is why I find it very important that people that want to get into the field get their certification and then move on in the field. So what they're saying is, if you own your own company or if you work for a company and you're out there working on refrigeration equipment and you're opening up systems and stuff like that, you're trying to replace a compressor or you're opening up the system to evacuate it and recharge it, you shouldn't be doing that. And if you are, you get fined, or the company you work for will get fined $27,500 per day per violation. And trust me, these inspectors, they go around looking for this stuff every day. So if you're out there doing it, get your certification and then continue on, or just stop doing it. And then also, if you say somebody that is working on refrigerant or refrigeration equipment and they don't have their certification, you can go and turn them in to the EPA, and the EPA will pay you $10,000. So, when people know this, they would they'll also be the watchdogs for the EPA. So that's why they do it. Service technicians who violate Clean Air Act provisions may be fined, lose their certification, and may be required to appear in federal court. The EPA may require technicians to demonstrate the ability to properly perform refrigerant recovery recycling procedures. Failing to demonstrate these skills can result in a revocation of your certification. So, what that means is you can be out in the field working on some equipment, and just say you're only cleaning, cleaning the equipment or something like that, and they know you're there working. The EPA inspector can come up to you and ask you to show him how to evacuate a system, or how to recycle. How do you recycle? And they want you to show them with the equipment there. So, you got to be aware of this, because they may come up to you and do that. These are things that happen and out there in the field. You just never know. It is a violation of Section 608 to falsely or fail to keep required records. I hope you guys are taking some notes, because this stuff could all be on the exam. It is a violation of Section 608 to fail to reach required evacuation rates prior to opening or disposing of appliances. Knowingly release or vent CFCs, HCFCs, or HFCs while repairing appliances, with the exception of de minimis releases. And that de minimis, what they mean there is that what they were talking about when I was showing you those gauges, and they were saying that they would rather you use the gauges with the low loss fittings. That's what they're talking about. They want minimal releases into the atmosphere. Okay, violations of Section 608, service, maintain, or dispose of appliances designed to contain refrigerants without being appropriately certified as of November 14th, 1994. You want to remember that date. It is the responsibility of the final person in the disposal chain to ensure that refrigerant has been removed from appliances before scrapping. So with those refrigerators and coolers or whatever you're throwing out, they have to be properly evacuated. The compressors have to be properly evacuated and properly disposed of. So, you need to know this. Another violation is if you vent CFCs or HCFCs since July 1st, 1992. If you vent HFCs since November 15th, 19